Here we have an interesting question where we have a parallel plate capacitor, so of course C is equal to A epsilon naught over D, and in the problem we don't know the initial voltage V, um, and we don't know the initial distance D. We do know the initial area A, but then we're just given the change in distance delta D and the change in voltage delta V. And we're asked to work out the charge on the capacitor. So let's see how to do that. Alright, so this problem, we start the same way as we did last time. A voltage connected to your capacitor, V, whatever, C naught we'll call it. So, that's V naught, okay. So then we end up with some charge Q, which is equal to C naught V naught, and then we disconnect the circuit. So then that means the charge is locked in place. And then we change our capacitance. So our C1 is equal to A epsilon naught over D plus delta D, whatever your delta D is. I guess I should write what C naught was as well. Epsilon naught over D. Great, so and then our V naught, or new V, is just simply the old V plus whatever difference the problem gives you. So now the same charge, because remember they can't change, so Q is equal to C, here, I'll write it out as, yeah, sure, A epsilon naught over D times V naught is also equal to C1 V1, which is A epsilon naught over D plus delta D times V naught plus delta V. Now we can cancel those out. We find V naught over D is equal to V naught plus delta V over D plus delta D. Now between the two of these we can do some cross multiplying. Thus V delta D is equal to V naught D plus D delta V. So those cancel out. We find V is equal to delta V over delta D times D. Now that's perfect because if we remember, we said Q is equal to A epsilon naught over D times V before. So now if we just plug in our new equation for V, find A epsilon naught over D times delta V over delta D times D. Those go away. And now we have charge in terms of things we know. A epsilon naught delta V over delta D. And there's your answer.